Good morning. Okay. All right. So we're working our way through all these fundamentals, right? So kind of dealing with factoring is where we left off a little bit, and then dealing with rational expressions in 1.4. So we did jump around a little bit. Because last day we introduced the quadratic formula, which helps us factor a quadratic equation, which is really nice. So, so I kind of wanted to introduce that to save us a lot of headache. I have kind of been playing it by ear to see how long it takes us to get through these fundamentals. It looks like we're going to finish next week. So, so what I want to do is, usually I like to have a test before Thanksgiving, but because it's not a day off for us, because it's on a Monday, what we're going to do is we're going to have the review on the Tuesday after Thanksgiving, and then we're going to have the test on the Thursday. So definitely take the time to obviously review before our review class, and then we can kind of iron out any kinks we have. So test number 1 is only on the fundamentals. Oops, fundamentals. And we'll do a review day on October 13th, I think, yeah. On October 13th, and test number 1 on October 15th. Okay, so that's important. But I always like to do a review day in advance, and because it's I don't want to say just the fundamentals, but it is, because it is a lot of material that we've gone through. Some should be review, some might be kind of fresh wounds, so to speak. But we'll go through a practice test together. I'll make it available beforehand so that way you can try it out before the review day. And so I will post a practice test before Thanksgiving. Oh, I guess it's capitalized. Thanksgiving, for you to work through. And then we will go through it together in the review class. We will go through it together in the review class. Okay. So the review, the practice test, there it is. The practice test, these questions will be very similar to the questions that you've had in these handouts. Now, I know there weren't any questions, but we went through questions. So for example, here, right, kind of look at these and, oh, that's what this morning I was like, there's something I'm forgetting. I'll post the solutions to the 1.4 and the 1.5 questions as well. You have the 1.3 and there's lots in 1.3. Well, this is 1.4, but there's lots in there to kind of work through. Oh, do we get a formula sheet or you get to make one? Well, Usually I would get you to make one, but honestly, because you're doing this test at home, you can have whatever you want, right? So I am going into it assuming that you're going to have all your resources available, right? What makes it tricky is the time constraint, right? And so we'll be doing it in class or like during class time. So so definitely take some time to make a formula sheet with all those go-to things that you want to have available, right? That's a really good way of studying, just kind of going through and saying, oh, what do I need here to make my life easier during the test? Kind of a piece of advice is don't overwhelm yourself, right? If you kind of know where to go and to find information quickly, then that's good. Sometimes a huge piece of paper with all this information on is kind of tough, but I'll let you figure that out. So I am assuming that it's open book. So go ahead and take advantage of that. Of course, you know, plagiarism still is a thing. So I don't want you working together on the test, of course. Work on your own stuff. Blah, blah, blah. So I'll put it on the, since you will be writing the test at home, presumably you're at home, test at home, it will be kind of open book, as we say. Hey, my smiley face a little crooked. Open book can be kind of tricky, right? So kind of prepare for that. Okay, so so it is open book, and kind of take advantage. Any questions about all this stuff? No? Good. All right. So good. We'll do a little kind of recap of what we did last day. The main thing is we introduced the quadratic formula to be able to easily factor quadratics, right? We use the quadratic formula to solve quadratic equations. And a quadratic equation is something like ax squared x plus bx plus c equals 0, right? And the quadratic formula, eventually you'll have it memorized, I promise, even though it looks nasty right now. Negative b plus minus the square root of b squared minus 4ac all over 2a. Because we're going to use this to find the solutions, and then we use the solutions, right? So we use it to solve the quadratic equation, so we solve for x, and then we use the solutions to factor the quadratic equation. Use the solutions to factor quadratic equations. And we'll see that again today, so not to worry. And then what did we do? Oh yeah, then we just kind of talked about rational expressions. Rational expressions are just kind of, I don't know, polynomial looking things as a fraction. I'm just looking back at an example that we did. Maybe we'll start another example. We'll start on so we worked through some of these. We were multiplying and dividing fractions, but now these are rational expressions, right? And so we already did 28, right? How about we do 35, just because it's the first time that we see kind of a fraction over a fraction. So we are dividing, right? And it looks kind of nasty here, but I'll cut it out and see what we get. So we're going to do 35. So 35, we've got x to the 3 over x plus 1, and then that's all over. So notice how I extend the line a little bit just to indicate that, okay, I've got this fraction in the numerator, and then I've got another fraction in the denominator. And so over x squared plus 2x plus 1. We remember dealing with fractions, right? So we know from earlier, we know how to divide a fraction, right? So a fraction over a fraction, you flip the denominator and you multiply, right? So the same thing goes with, here's a fraction over a fraction. We're going to flip the denominator and multiply these two things. So what this becomes is x to the 3 over x plus 1 times flipped x squared plus 2x plus 1 divided by x. So already I'm seeing a couple of things that I'm able to cancel maybe. So because I'm multiplying here, I'm allowed to cancel. Okay. So here, so this can cancel, right? It's going to cancel x, oops. It's going to cancel this x, and then x to the 3 becomes x squared, right? Technically, what we're doing is we're bringing this x to the -1 up to the numerator, right? And then x to the 3 times x to the -1 is x to the 3 minus 1, which is x to the 2. But really what we'll start doing is we'll say, okay, 3 cancels, this cancels, and I'm left with just 2 here, right? So it becomes, let's write this out, x squared over x plus 1 times x squared plus 2x plus 1. That's fine. Okay. I cannot cancel this plus 1 with this plus 1, for example, right? Because everything is over. Because I'm multiplying here, everything is over. Remember, a fraction times a fraction, they get smushed together. So technically, everything is over x plus 1 here. So I'm not able to cancel because I'm adding in here and adding down here. So I can only cancel if things are being multiplied. Now, what I can do, and what you might have noticed already, is that this looks like one of those special factoring formulas, right? We've got x squared plus 2x plus 1, and if you flip back to those special factoring formulas, you'll see that we can rewrite this as a perfect square. notice that, remember, a squared plus 2ab plus b squared, we can rewrite as a plus, a plus b squared. So we recognize this pattern as x squared plus 2 times x times 1 plus 1 squared, right? And so we can rewrite this as x plus 1 squared. So that's what I mean. It's going to be helpful to start recognizing we definitely could go through and use the quadratic formula to find the solutions and then factor it that way. But you don't have to, right? So, so this becomes x squared plus 2x plus 1, we can rewrite as x plus 1 squared. Okay. Just to check my work, right, especially if you're not feeling 100% confident, then it's worthwhile expanding this just briefly, just to see, just to make sure that it's the right factor. So we can check by doing x plus 1 times x plus 1. That's x plus 1 squared, which is x times x, which is x squared, x times 1, so x plus 1 times x is x, plus 1 times 1 is 1. This is x squared plus 2x plus 1, so we are good to go, right? That was just a little side check. So what I'm going to do, right, is I'm going to rewrite this as x plus 1 squared factored. And the reason I want to do that is, one, it's easier to look at, right? But also because I've got this x plus 1 down here in the denominator that I'll be able to cancel one of these x plus 1s with, right? So what we have, just kind of picking up, maybe I'll move it down the line. This becomes x squared over x plus 1 times x plus 1 squared. Again, because I'm multiplying here, I'm allowed to cancel these guys, and I can, just to make it easier to see that I can cancel, I'll put brackets around x plus 1, there's no harm in that. So what I'll do is I'll kind of show here, whee, there, and this square cancels with this whole thing. So now what we have is we're left with x squared times x plus 1. You can leave it like this, or if we want to kind of simplify and remove all the brackets, x squared times x is x to the 3 plus x squared times 1 is x squared. Okay. So really useful to be able to recognize that this is one of those special factors and just use that, right? Because here, we could have skipped straight from here to down here, and that would have been fine. Right here, I just want to show you what happened. Okay. Let's do this itty bitty 38, x over y over z. So for 38, we've got x divided by y divided by z. I'll make that kind of sharper. Maybe. We still have a fraction over a fraction, right? X you can rewrite as x over 1, and then you've got y over z, so then you can still flip and multiply, right? And we've seen that before, where it's just easier to rewrite x as x over 1, and so we can say we've got x over 1 divided by y divided by z, right? Now it's clear that I've got a fraction over a fraction. So now I know what to do, right? I flip and multiply, so I flip the denominator and I multiply. So now I have x over 1 times z over y. I'm just multiplying fractions here, so I can multiply across xz over y. Is the simplified version. Okay. Any questions about that? Okay. So, awesome. We know how to deal with fractions, right? So we've already talked about how do we deal with fractions, but we're just applying it to these kind of trickier rational expressions. And so we can add and subtract rational expressions, just keeping in mind that we still need that common denominator, right? And so we can add and subtract rational expressions keeping in mind, we still need a common denominator, right? Just like before, but now that common denominator is going to be some sort of expression. Right? So let's pull in some of these here. I'm going to use the same trick. So this little blurb here says, okay, we should be using the least common denominator, and often in these things, the way that we do it or we're doing it will yield the least common denominator, but not always. I would still say that the safest way to find the common denominator is to, so if we look at 43, for example, if we were dealing with that one, 3 over x plus 1 minus 1 over x plus 2, I need a common denominator down here. Zoom in. I need a common denominator here. And so that common denominator, the easiest thing to do is going to be make the common denominator x plus 1 times x plus 2. So to this first term, you have to multiply by x plus 2 over x plus 2. And to the second term, you have to multiply by x plus 1 over x plus 1. Right? Multiplying by 1 doesn't change anything, so we're allowed to do that. In fact, how about we do 43 just to see what's going on here. So let's do 43. If I'm just stealing it from over here, is 3 over x plus 1 minus 1 over x plus 2, right? Making a couple of notes as we go here, right? Need a common denominator because we're subtracting, adding or subtracting, we need a common denominator. The easiest common denominator, oops, I always want to combine words, common denominator, what a mess, denominator is the first I guess I have to write denominator again. The first denominator times the second. Okay. In this case, it would be x plus 1 times x plus 2 is our easiest common denominator. So what that means is, I'll rewrite it out here, 3 over x plus 1 minus 1 over x plus 2 is going to be 3 over x plus 1. To get that common denominator, right, I'm going to multiply by x plus 2 over x plus 2. So remember again, when I'm working on this term, this first term, I glance over here on the next term and I just make that my easy value of 1, right? X plus 2 over x plus 2 is 1. So I'm technically multiplying by 1, which I'm allowed to do, right? And then same thing with the next term. When I'm looking here, I glance over here and I say, okay, well, I need an x plus 1. So that's going to be my convenient value of 1. So minus 1 over x plus 2 times x plus 1 over x plus 1. Okay. Now I'm just multiplying, multiplying fractions here and here. So I'm going to do that first and kind of smush them together. And so this becomes 3 times x plus 2 over x plus 1 times x plus 2 minus x plus 1 divided by x. And I'm going to write them in the same order. X plus 1 times x plus 2, just to show that they're the same. X plus 1 times x plus 2, because I forced them to be the same, right? That's the whole idea. Because I have this common denominator now I can smush these together. I can subtract the numerators over this common denominator. So what I get is I get 3 times x plus 2 minus x plus 1 all over that common denominator of x plus 1 times x plus 2. Maybe what I'll do is I'll try to simplify the numerator a little bit. I'll expand the 3 inside, expand this negative in here, and see if I can simplify it a little bit. So I'll do 3x plus 6 minus x minus 1 over x plus 1 times x plus 2. I would hold off on expanding this, right? Because sometimes we might be able to cancel one of these factors. And so if we've got something factored, I prefer to hang on to it for as long as possible, right? Because for me, expanding is a lot easier. Whereas factoring, if I have something factored, I'm not going to let that go, at least not too quickly. So I'm going to simplify this and see where it gets me. So here I get 3x minus x puts me at 2x, and then 6 minus 1, so plus 5 over x plus 1 times x plus 2. I don't really see anything that's kind of jumping out at me to be able to simplify this anymore. I mean, I guess I could pull out a common 2, but then this would become a fraction, right? 5 over 2, which isn't that nice to deal with. So I would say here, I'm done. What I'm looking for, if I were able to pull out either an x plus 1 or an x plus 2 here, that would be great, right? But it doesn't look like I can, so that's all right. We're done. Let's see here. me just make a note here. This is the one we did. Let's do one with 3 terms in it. Right, let's do 56 together. So 56 is a little bit long. X over x squared minus x minus 6 minus 1 over x plus 2 minus 2 over x minus 3. Now, you could just blindly jump in and say, okay, I'm going to go through and I'm going to find this common denominator, and this common denominator is going to be this times this times this. Right? You can do that, but it's a little bit bulky. So what I would prefer for you to do is try and see if you can factor this, and if this factor has even one of these, x plus 2 or x minus 3 in it, then that simplifies your common denominator quite a bit, right? And so, so we'll try to factor this. Try to factor this to see if x plus 2 or x minus 3 are factors, right? This will simplify the common denominator. Okay. So kind of as a side note here, right, if I've got x squared minus x minus 6, I don't know about you guys, but I'm not seeing how this would factor easily. So whenever I come across something like that, I'm just going to use the quadratic formula, right? And so here, the solutions here are x is negative b plus minus the square root of b squared minus 4ac over 2a, where A is 1, B is negative 1, and C is negative 6. Maybe I'll even, bring this down a little bit here. Whee! To the next page. So, right, we did this a lot last day, but it's good to kind of get in the groove again. Negative b is negative 1 plus minus the square root of negative 1 squared minus 4 times a, which is 1, times c, which is negative 6. All over 2 times a, which is 1. 1 plus minus the square root of, and I'm just going to skip to 25, right? 1 squared or negative 1 squared is just 1. Make sure your calculator isn't giving you a negative, right? That means you have to put the negative 1 in brackets because it's negative 1 squared, not negative 1 squared, right? It's a difference. 4 times 6 is 24. 4 times negative 6 is negative 24. So 1 minus negative 24, 1 plus 24 is 25. Skipped all that, and that's okay, right? In fact, it's kind of where I expect us to be at. Over 2. Okay. The square root of 25 is 5, so I get 1 plus minus 5 divided by 2. So x is going to be 1 plus 5, which is 6 divided by 2, and x is going to be 1 minus 5, which is negative 4 divided by 2. Right? Here, 6 divided by 2 is positive 3. Negative 4 divided by 2 is negative 2. Right? So these are the solutions to this thing if we set it equal to 0. Right? And that's what we're going to use to develop these factors. Right? But we have to remember that positive 3 should make it 0. So if x is positive 3, we need to get 0. And if x is negative 2, we need to get 0. So now we use the solutions to develop the factors. So we have x minus 3 times x plus 2, right? Notice if I put in x equals 3 here, right? 3 minus 3 makes 0, so this whole thing goes to 0, which is a solution, which is what it has to be, right? And then same thing with the negative 2. If I plug in negative 2 here, negative 2 plus 2 is 0, so again, this whole thing would go to 0, and so they are solutions. So we'll just check to make sure that it expands into what it should expand to, just so we're not factoring incorrectly. Check by expanding. We've got x minus 3 times x plus 2 is going to be x times x, which is x squared. X times 2 is plus 2x. Minus 3 times x minus 3x. Minus 3 times positive 2, or negative 3 times positive 2 is negative 6, putting me at x squared. 2x minus 3x, negative 1x, but I'll just write x, minus 6, which is hopefully x squared minus x minus 6, which is what we wanted. Right? So, right, what we can do is we can take this original thing that we're working on, and I'm just going to steal it here. Copy. Paste. So what we're going to do is we're going to replace this here, right? Since they're the same, they're equivalent. So this becomes, oh, I shouldn't have done it so lofty. I'll start writing over here my equal sign. I'm always trying to stack my equal sign, so I can already tell that I'm going to need a lot of space, right? Because I need to find common denominators all along here, which means I'm going to need to multiply by 1 a lot, right? 1. So I've really got x times, x over x minus 3 times x plus 2 minus 1 over x plus 2. And what I'm going to do is I'm going to write these in brackets, because what I'm seeing is I've got x plus 2, and x minus 3, x minus 3. Hey, what luck? Not really, but we'll pretend. 2 over x minus 3. Okay. So looking at this, x minus 3 times x plus 2, here I've got an x plus 2, here I've got an x minus 3. A common denominator that I can get easily is x minus 3 times x plus 2. So here, the common denominator is x minus 3 times x plus 2. So what I need to do is I multiply the second term. So this one is already over the common denominator. So the first term is fine. The second term I need to multiply by x minus 3 to get to that common denominator. And the third term I need to multiply by x plus 2 in order to get this common denominator. So what I get is I get x over x minus 3 times x plus 2 minus 1 over x plus 2, oops, and then times x minus 3 over x minus 3 minus 2 over x minus 3 times x plus 2 over x plus 2. Same trick we've been using for a while now. Make sure this doesn't get cut across the page here. There. So if I expand this here, I'm just multiplying fractions, so I can expand these and just kind of make sure that you keep them as x minus 3 times x plus 2, or vice versa, it doesn't matter. A times b is the same as b times a. So, but it might be nice to have them all in the same order so they actually look like a common denominator. So I'm going to write them in this order, but I wouldn't expand them quite yet. Like I said, if you've got something factored, I would hang on to it for as long as you can. So this becomes x over x minus 3 times x plus 2 minus 1 times x plus 3. I'm just going to write x minus 3 divided by, and here I'm going to rewrite the order of this just to match the first one. So x minus 3 times x plus 2, but we force them to be the same, so we're safe. Minus 2 times x plus 2 divided by x minus 3 times x plus 2. So now I have this common denominator, right? Which means I can combine everything in the numerator and put it over that common denominator. So what I have is I get x minus 3 minus 2 times x plus 2 all over x minus 3 times x plus 2. What I'm going to do is I'm going to carefully simplify the numerator, right? Expand in this negative into the x minus 3 and expand this negative 2 into x plus 2 and just kind of see where we get to. So we get x minus x plus 3 minus 2x minus 4 over x minus 3 times x plus 2. X minus x, well, those go away. 3 minus 4 puts me at negative 1, right? So I've got negative, if I want to write the 2x first, negative 2x minus 1. Let's see where we end up here. Negative 2x minus 1 divided by x minus 3 times x plus 2. To make things a little bit nicer looking, I can pull out a negative here. Just being careful, right? And it's a good exercise to pull out this negative. Just being careful that if you bring the negative outside, then you would have 2x plus 1 times negative 1. Okay. Let's see here. Negative 2x plus 1 divided by x minus 3 times x plus 2. And I'd say that's as far as we can go, right? Again, I'm scanning the numerator to potentially be able to cancel with one of these guys. If I could pull out a common x minus 3 or a common x plus 2, then that would be great, but I can't. So we're done. In my notes, I had done it wrong. There. That happens. All right. Okay. So let's see here. Let's go back into the notes. So compound fractions are really just, you know, if we've got kind of fractions and basically a fraction over a fraction, right? But it could be 1 plus 1 over x over 1 over x minus 2, right? So not all of it has to be a fraction in order to be a compound fraction. In fact, usually it's split up. So what you want to do when you're dealing with and simplifying compound fractions is you want to find common denominators and just kind of zip it up, right? I don't know how else to kind of say it, but looking at this first one, right, 59, for example, we would need to find a common denominator up in the numerator and then a common denominator in the denominator, which sounds kind of weird, right? But then you're going to end up with a fraction over a fraction, which is what we were just dealing with, right? And then you can simplify it just like we did. So it's just another step that we would do. And just for, I don't know, for practice, let's do 72 because it's got a fraction. It's got 1, 2, well, sort of, it looks kind of like 3 fractions in there, but it needs to get zipped up, right? So this in here. Uh-oh. I didn't pull in the whole problem of the one we're working on there. Okay, so we'll do this one because I would say it's the, well, it looks the same as 71, but it's plus, so, and I'd say it's about the nastiest one on here. All right, let's see here. I've got 72, which is 1 plus, and then 1 over 1 plus 1 over 1 plus x. Okay. We need to simplify this, and we can, right? First thing I'm going to do is I'm going to put this fraction, right? Technically a fraction plus a fraction, so I need to have a common denominator. So I need to solve this first, put it over a common denominator and combine it as one fraction. And then I'll have a fraction over a fraction, right? 1 I can rewrite as 1 over 1. So then I'll have a fraction over a fraction, which is fine, right? A fraction over a fraction I can simplify by flipping and multiplying, right? So that'll be simplified. And then I've got 1 plus a fraction, but I can rewrite this as 1 over 1, right? And so then I've got a fraction plus a fraction, meaning I need a common denominator, and then I'll be done, right? Once I have that common denominator and I simplify. So this is going to become, so I'm just going to ignore this kind of outside part, and the first thing I'm going to do is find a common denominator here. Kind of start from the inside of the onion and then work your way out, if you want to think about it that way. Maybe the onion wasn't a good analogy, but that's okay. to get this over a common denominator, right, I need a denominator of 1 plus x. So my 1 is going to be 1 times 1 plus x over 1 plus x. Plus 1 over 1 plus x. Okay. Putting me at 1 plus 1 over 1 times 1 plus x is just 1 plus x, plus 1 over the common denominator of 1 plus x. So I'm not going to write all those steps out anymore because I don't really need to. We've done enough of these. So 1 plus x plus 1 over 1 plus x puts me at 1 plus x plus 1 over 1 plus x is my common denominator. 1 plus x plus 1, I can simplify, right, as 2 plus x if I want to. So let's do that. 1 plus 1 over 2 plus x over 1 plus x. Notice that I can rewrite this as 1 over 1, and so that makes this a fraction over a fraction. So I'm going to do that in order to simplify this a little bit, right? Because a fraction over a fraction, we know how to deal with that. So this becomes 1 plus 1 over 1 over 2 plus x, and I'm dealing with a page break here, over 1 plus x. Now I've got a fraction over a fraction here, so I've got 1 plus 1 over 1 times, and I flip and multiply, right? 1 plus x over 2 plus x. Okay. 1 times 1 plus x is just 1 plus x. So this puts me at 1 plus x. And you can keep the brackets if you want to, but I'm gonna leave them out. 1 times 2 plus x is just 2 plus x, so over 2 plus x. This already looks a lot better, right? So we just had to kind of zip it up. And so now I need this 1 over a common denominator of 2 plus x. And so I'm going to multiply 1 by 2 plus x over 2 plus x, and then I'll be able to simplify. So this becomes 1 times 2 plus x over 2 plus x plus 1 plus x, and I'll put brackets around that, even though I'm adding so it's safe, but just in case, over 2 plus x. 1 times 2 plus x is 2 plus x over, oh, I've already got that common denominator, so I'm going to smush up the numerator. So 2 plus x, put brackets around, plus 1 plus x. I don't need these brackets, right? I'm not multiplying anything. And it's positive out front here. If it's negative, then the brackets are important. But because I'm just adding across here, I'm safe, but it's just nice to have this kind of breakdown. Over 2 plus x, which is now my common denominator. Now I'm going to get rid of these brackets and simplify. So 2 plus x plus 1 plus x puts me at 2x plus 3 all over 2 plus x. And I'll ditch these brackets because I don't need them anymore. Again, I'm going to see if I can pull out a 2 plus x or even an x plus 2. Remember, x plus 2 and 2 plus x, they're the same, right? So if I could pull out a 2 plus x from here, from the numerator, then that would be great. It doesn't look like I can, right? 2x plus 3, there's no x plus 2 in there that I could kind of extract, and that's all right. So I guess I'm done, right? Okay. So we're going to be really good at dealing with fractions, but especially finding common denominators and simplifying fractions if we're adding or subtracting. Multiplying and dividing fractions is actually, I would say, pretty easy, but you need to do a lot of them. So let's see here. So we're not gonna develop these difference quotients, they're called, quite yet. But it is a good exercise to be able to simplify something like this, right? And so this is what's called a difference quotient, and I'm pretty sure we see them later on because it is a good exercise for dealing with functions. But for now, let's just look at how we can simplify this thing. So we're not constructing it, we're just simplifying it. And so let's do the first one, and then I'll leave you to do the second one later on your own. So for 73, we've got this kind of compound fraction style thing going on here. 1 over 1 plus x plus h minus 1 over 1 plus x all over h. So here, right, what I'm going to do first is I'm going to put this numerator over a common denominator, right, and then treat h as h over 1, and then I'll have a fraction over a fraction that I can flip and multiply and simplify. The hard part is figuring out what my common denominator should be up here. So I'm just going to use my go-to tactic, right? 1 over 1 plus x plus h, and then times 1 plus x over here, so times 1 plus x over 1 plus x, and then over on the second term, I'm going to do times 1 plus x plus h over 1 plus x plus h, right? Just forcing this denominator times this to be my common denominator. Not the most elegant way, but it is the easiest way, and it is the kind of most foolproof way. If you're able to find common denominators by some other means, then that's great, right? But I'm just showing you how to do it safely. 1 over 1 plus x plus h times 1 plus x over 1 plus x minus 1 over 1 plus x times 1 plus x plus h, trying to squeeze it in here, 1 plus x plus h, divided by h. I can expand the numerator as well as put it over this common denominator that I've forced, right? So I'm slowly dropping steps as I go here as we get more comfortable. So we get 1 plus x minus 1 plus x plus h. Notice that I kept this negative outside the brackets. It's technically minus 1 times 1 plus x plus h, because I don't want to expand this out quite yet. I want to be careful when I do that. So for now, I'm just combining these common denominators. 1 plus x plus h times 1 plus x is my common denominator, and this is all over h. I would say over h over 1, right? You can always rewrite 3, for example, as 3 over 1, and that's still safe, right? 3 divided by 1 is just 3. And so now I've got a fraction over a fraction. I'm going to do a little bit more work to try to simplify the numerator in the numerator. But I'm going to leave the denominator factored like it is. Okay, so let's see here. So I get 1 plus x minus 1 minus x minus h divided by 1 plus x plus h times 1 plus x all over h over 1, let's say, because we introduced that already. Some things cancel to make my life a little bit easier here. 1 minus 1 goes to 0. X minus x goes to 0. So really all I'm left with here is negative h. So this becomes, I'll put it on the fresh page here. I get negative h over 1 plus x plus h times 1 plus x all over h over 1. Hey, this is looking good. Why do I say that? Well, I've got a fraction over a fraction. When I flip that h over 1, it becomes 1 over h. And it looks like I'll be able to cancel those h's. Which, I mean, we haven't done difference quotients yet, so, but that h will always cancel, and that's what's so nice. Because if you're finding that the h's don't cancel, then you've done something wrong, right? So you get negative h over 1 plus x plus h times 1 plus x times 1 over h. Because I'm multiplying here, oops. Because I'm multiplying here, I'm allowed to cancel. So this becomes negative 1 divided by 1 plus x plus h times 1 plus x. And I would just leave it like that. I wouldn't expand it. Okay, good. So there are a couple more in the notes, but they're on the next page here. Some of those are a little bit tricky, right? But I'll leave those for you guys. Same thing with these ones. We're not going to spend time on these. It's good practice for your exponent laws and also your fractions. But let's just talk about rationalizing the denominator or the numerator. Usually we're rationalizing the denominator, and it is more something that you would use in calculus if you end up taking calculus. But it's just a good thing to keep in mind. So what we mean by rationalizing the denominator is if you have something like 5 minus root 3, okay, or even root 2 plus root 7, if you want to get rid of this root, and we've already seen this similar situation before, then what we do is we multiply by the conjugate radical, meaning if we have 5 minus root 3, what we do is we multiply by 5 plus root 3 to get rid of this root. So to rationalize the denominator, same thing goes for the numerator, or numerator, means to Move the square root means to move the square root from the denominator. It has to go somewhere, so from the denominator to the numerator, or vice versa, right? If it's in the numerator. Okay. We rationalize by multiplying by the conjugate radical. Right? So if we have something like a plus b root c, right? So here, just make a note what we want to rationalize. Oops. Then the conjugate radical, we multiply by, so I'll put these in brackets just to emphasize that we're multiplying here. Then we multiply by a minus b root c, so everything stays the same except the sign here. This is the conjugate radical. So something really pretty cool happens is if you have something like a plus b root c times a minus b root c, and we've seen this as our special factoring formulas, but it's nice to kind of do it again. I'll scoot this over so I have some room to expand this, because what I'm going to do is I'm going to expand this out and see what it ends up looking like. So this becomes a squared minus ab root c, right? A times negative b root c is ab root c. And then I get plus ab root c if I rearrange the a and the b. So plus ab root c. And then b root c times negative b root c puts me on negative b squared c, right? Root c times root c. So then I ran out of room. My negative b squared root c, which is just going to be c. So we get a squared. I'll just make a note here. These guys go to 0. So I get a squared minus b squared c. Okay. It's kind of hard to see with these letters. A lot of the time the b is going to be 1, right? So then we get a squared minus 1 squared c. So then it's just a squared minus c. But sometimes there's going to be a coefficient or a multiplier in front of the root, and we can deal with that, right? You don't need to memorize this. I just want to show you what it looks like in general. So let's see here. You know what? I should move this down. I'm going to do some rearranging here and see if I can get all these on the same page. Good. Nice. Cool. Some quick rejigging there. So we'll start nice and slow. How about we do the, let's do 86. So if I want to rationalize the denominator, what that means is I don't want this square root 5 in the denominator anymore. So what I have to do is I've got 3 over 2 minus root 5. I'm going to rewrite this by multiplying by 1, multiplying by the conjugate radical of this guy, 2 minus root 5. The conjugate radical would be 2 plus root 5, right? The only thing that changes here is the minus goes to a plus. So now I'm at 3 over 2 minus root 5. I'll put brackets around here just to emphasize, because now I'm multiplying by 2 plus root 5 over 2 plus root 5. Okay. Now I'm going to expand the numerator, expand the denominator because I'm multiplying here, so I'm allowed to do that. See where we end up. So I get 3 times 2, which is 6, plus 3 times root 5, so 3 root 5. Now I do have this root in the numerator, but because the goal was to rationalize the denominator, I'm only concerned if I still have roots in the denominator, right? The root had to go somewhere, so if we're rationalizing the denominator, we're essentially moving the root upstairs. And then if we expand this, 2 times 2 is 4. 2 times plus 2 root 5 minus 2 root 5. Hey, looks good. Negative root 5 plus root 5 is minus root 5 times root 5. Root 5 times root 5 is just 5. So what I get here, 2 root 5 minus 2 root 5, that's going to go away. Root 5 times root 5 is just 5. So I get 6 plus 3 root 5 over 4 minus 5. 4 minus 5 is negative 1. 6 minus 3 root 5 divided by negative 1. I don't want to write it like that, right? Over negative 1, I would have to put this negative out front here, right? And then I can get rid of this denominator. So now I'm out of fraction town. So now I have negative all in brackets, right? So when you bring that negative from the denominator up, you have to multiply it all by negative 1. So then, 6 plus, thank you. Bink, bink. Tim's on the ball. Good. So now, just to simplify things, I'm going to bring this negative inside or just leave it outside. It doesn't matter. Maybe we'll just leave it outside. Makes it look nicer. Otherwise, it'd be negative 6 minus 3 root 5. Cool. So now we don't have a radical in the denominator anymore. What if we had to rationalize the numerator? So the same deal goes. Let's see here. Now we've got these roots in the denominator, and because I want to keep practicing with fractions, what I'm going to do is I'm going to leave these guys. How about we use the r? So the root of r plus the root of 2, and then times 5. Okay. So let's do 93. Got the root of r plus the root of 2 over 5. Okay. it's okay that this is a root, right? What we want to do is ideally we want to get rid of both of these roots, and we will, as long as we take the root of r minus root 2 as our convenient value of 1, right? So again, we're still going to use the conjugate radical, and just make sure that you end up with no roots in the numerator. That's the whole goal, because we're trying to rationalize the numerator now instead of the denominator. Root r plus root 2 over 5 times, so now I'm looking at this thing and I'm saying times, I'm going to put brackets around here, root r minus root 2, and hopefully things will just kind of shake out when I expand this, over root r minus root 2. So this, when I expand root r times root r, that's just going to be r. So I'm going to skip that step of writing out root r times root r, and I'm just going to write it out as r. Root r times negative root 2 puts me at root r, so minus root r root 2. Positive root 2 times root r, again, and what I'm going to do is I'm going to rewrite it in the same order that I have here, just to make it easier to see that they cancel, but I also know that they will. So plus root r root 2, oops, no bracket. And then root 2 times negative root 2 puts me at negative 2. All over 5 times root r minus root 2. Okay. So the goal here is to get rid of any square roots in the numerator, and it looks like we've managed. Negative root r times root 2 plus root r times root 2, those go to 0. So now I'm left with r plus, or r minus 2. R minus 2. Here in the denominator, sure, I'll expand it in. So I get 5 root r minus 5 root 2. And then I'll be done. Oops, 5 root r minus 5 root 2. Nice. So now, remembering that the goal was to rationalize the numerator, so I don't have any roots in the numerator, and that was the goal, right? The roots have to go somewhere, and so now they're down here in the denominator, right? But the trick is to find the conjugate radical and then use that as your value of 1. So then the last little bit of the 1.4 notes are just highlighting some common errors, right? So I'll leave those for you guys to read through and see, you know, why is a plus b squared not equal to a squared plus b squared? We already looked at that, right? If we're adding or subtracting inside the square root, we can't break up the square root, right? So it's just some common errors that, well, they're very common, so that people make all the time. So you just want to kind of keep those in check and kind of drill them into your head. Okay, so that is the end of 1.4, and we did 1.5 last day, kind of in a weird order. I'll have to rejig my notes, but that doesn't help you guys. Next week, we're gonna deal with inequalities and lines, and then that'll be the end of our fundamentals section. So This is the end of fundamentals part 2, and we did fundamentals part 3 out of order last day, right? That was the quadratics. Next week, we will do inequalities, less than, greater than, not equal to, inequalities and lines, right? So graphing lines. How do you know if two things are parallel or perpendicular and all that kind of fun stuff? And then that will be the end of the fundamentals. Right. Just so you know where you're headed. I was talking to Steve, my colleague, and I was like, it's taking me forever to get through all the fundamentals, but they're so important, of course, fundamentals. And he's like, yeah, same for me. But it is like a third of the course, so we are actually right on track, so don't worry about that. Kind of rude to call them fundamentals, I think, but because it's a lot of important stuff. But yeah, now you know where we're headed, and we'll have the test on just the fundamentals on October 15th, review on the 13th. Any questions? Oh, thanks, Ash. So the first quiz, or is it the second quiz maybe, is due tomorrow at 8. At 8? That doesn't seem like me. Oh well. Good reminder. Thanks, Ash. All right. Let's see if I can take us there. Touch too hard. So here, mine is all full of junk here. Let me try to switch it to student view, switch role to there, so I can see what you're seeing. Way cleaner. Oh yeah, so the intro to My Open Math, and then there's the intermediate algebra diagnostic. And oh, Tyler sent a link, so hopefully that works. I actually don't know if my iPad will, yeah, so my iPad doesn't let me go because I haven't linked my account, or I don't, because I'm in student view, it doesn't let me do it. Anyways, so there's an intro to My Open Math, which is just how do you do stuff in this program, which is kind of called My Open Math, or MOM, My Open Math. I think it's so funny when they call it MOM. But then there's an intermediate algebra diagnostic. Some of those diagnostic things will come up next week as well with inequalities and lines. But it might be a good exercise to just kind of try it out. Good. And if you click on those, it should tell you when things are due, right, and kind of the specifics. But like I said, it won't let me do it for some reason. How long is the algebra diagnostic? Now let me see here, asking the tough questions now. Wonder if we can go here. Yep. Oops. So this is what it looks like on my end. Of course, you don't have to deal with all these. Oh, if you've done all those, then no, you don't need to repeat it, as long as you have something. Okay, so the intro to my open math was due before. Hey. Weird. I'll make these due. How about I'll adjust these so that they're both due Friday at midnight. Just sorry if you've done these, but the intro to my open math was due yesterday at 8 a.m. I don't know why I picked 8 a.m. I could have sworn I usually make things due at midnight or 11:59. So let's go back in here and say intro to my open math and Algebra Diagnostic due Friday, so tomorrow, October 2nd at 11:59 p.m. And if you've already done them, don't worry about it. Right, I just want to make sure that everyone's in there and doing things. Great. So I'll change those due dates so you can have a stab at them. And if you've done them, sit back, relax, and enjoy your weekend. Any other questions? No. See ya.